In this lesson we're going to look at a new group of organic chemicals called the alkenes, as opposed to the alkanes which we looked at the previous lessons. So just like the alkenes form a homologous series, and what characterises the alkenes is the presence of a carbon-carbon double bond in each molecule. Now, it is precisely this double bond which makes the alkenes more reactive and therefore chemically more interesting than the alkanes. As we shall see in the following lessons, it means that chemically we can make more interesting substances with these than with the alkanes. And to start off with, let's just have a look at the first member in the series. So by definition, because you require a carbon-carbon double bond in the alkene series, then the first member of the series must have two carbon atoms, and that is ethene. So let's have a look first of all at the dot and cross diagram for ethene. So you can see each carbon atom shares a single electron with the electron from a hydrogen atom to form two covalent bonds, and another covalent bond here and here, and each carbon atom shares two electrons with another carbon atom to form a double bond. So we have four shared electrons between the two carbon atoms. So looking at the structural formula for this, you have a carbon-carbon double bond, and that double bond tends to push the carbon-hydrogen covalent bonds away from it, so it takes up this shape. Okay, so chemical formula for this is C2H4, and this is ethene, which is the first member in the alkene series. So the next member in the series is C3H6, which is propene, and the next member in the series has four carbons, and just like in the alkanes with the case of butane, butene has what we call isomers. So just remind ourselves that an isomer is a compound with the same chemical formula but with a different structural formula. So we have various possibilities for the four carbon setup, and the first one is with the double bond on the first carbon atom, and that is known as but, not butene but but-1-ene, because the double bond is on that first carbon. And likewise in the second case, the double bond is on the second carbon atom, which is therefore called but-2-ene, and you probably realised that there isn't a but-3-ene, because if you put the double bond on these carbon atoms, then it's really the same as but-1-ene, except rotated through 180 degrees. So you need to think about the spatial symmetry, what's going on there when you're naming these longer chain isomers. So we have but-1-ene, but-2-ene, and then as we learnt with the alkanes, this group here is called the methyl group, and so this would be 2-methyl propene, because the methyl group is on the second carbon atom. So this is known as 2-methyl propene. All right, and these all have the same chemical formula, which is, I'll just do it in red here so that you can see clearly, C4H8. So the general formula for the alkene homologous series is simple. We can say we have CN. For every N carbon atoms, there are 2 N hydrogen atoms. And then just emphasizing again that a homologous series is a group of chemicals or molecules with similar physical and chemical properties which can be represented by a general formula like this.